That's in general, not only along x, can be along any dimension. And it's the same. And this is a summary of the three formula. Okay. Let's work on the problem now. So get the study guide and go to question. So from 1 to 12 was vectors, right? 1 to 12 was vector analysis. We covered that in the first lecture. Now, second lecture, which is what we are talking about, go from 13, motion at constant acceleration. We'll go from 13 to 22. So this topic, motion in one dimension, go from 13 to 22. And let's start. I just will quickly review with you. I already covered problems, the general problem. Now we go to the particularity. I mean here, particular problems here, just to look at how to get or how to solve it. Question number 13. The position of a particle moving along the x-axis is given by x21 plus 22t minus 6.0 t squared. There is a point there. Barely you can see that point. Right? So x is 21 plus 22t minus 6t squared in meter, where t is in seconds. The question, what is the average velocity during the time interval between 1 and 3 seconds? Did we do this here? Yeah. Similar problem, right? Than the one that I did in class. Okay, in addition to that, I can ask what will be the velocity at 2 seconds. What do? We take the derivative and we plug it in 2. I can ask, at what time is the particle at rest? The derivative equals 0, and I get the time, right? What will be the maximum displacement of the object? Plug it into the original one, the time that we got. This is a review of the question, right? Now, of course, I don't have space to give all the possible questions. You know, I give some samples of the question. Okay, 14. The same thing. The position of a particle moving along the x-axis is given by the function. The question, what is the position of the particle when it achieves its maximum speed in the positive x direction? Maximum speed. When we get the maximum speed. So, you know that the speed is the derivative of the position, right? Now we have the velocity function. So, in order to get the maximum of the velocity function, what you have to do? Find the derivative of that, which is the acceleration. And you make the acceleration equal to what? 0. Right? You find the time, and then you have to come and find the maximum velocity. But they don't want the maximum velocity. They want, what do they want? The position. So it means you have to get, right, what is the position when the particle reaches the maximum speed? So it means, in order to get the maximum speed, the acceleration has to be 0. Right? So you need to go get the time for when the acceleration is 0. Once I get that time, I go and I want to get what will be the position. Where you go, to the velocity function or to the position function? The position function. Good. Then, so it's given here the velocity versus time, 15. The velocity is given as a function of time, right? They are asking, what is the acceleration of the particle when it achieves the maximum displacement? So it's an application, not just as simple as that. It's an application. What is the acceleration of the particle when it achieves the maximum displacement? Let's think. It's given the velocity. When did I say that the object reached the maximum displacement? When the velocity is 0. The velocity function is given? Is the velocity function given? Yes. So, since the velocity function is given, can you find where the velocity is 0? Once we get that, then what you have to get? We don't want the maximum displacement. What we want is what? The acceleration. So once we get the time, when the velocity is 0, that information is only to find the acceleration. What is the acceleration? How can we find the acceleration? If we have the velocity function, how can we find the acceleration? We derive and we plug it in the time that we found. Got it? This is the line of action. That all the questions will be like that in the test? No. I will give simple, but I can give one challenge. So maybe I will ask, this is the position, find the velocity at 2 seconds. This is straightforward, correct? But at a certain point, I can give also one that challenge. And for this reason, I am putting this the more difficult one. 16. We have a graph. B versus T. And the question is, find what will be the position, what is the position of the particle at 6 seconds. We want to get the position of the particle at 6 seconds. What can we do? The graph, what is the graph given? Velocity versus time. In the velocity versus time graph, how can we get the information about position or displacement? Finding the area under the curve, which is the integral, right? But here we have the actual graph. So we can get the area under the curve. It's given the initial position. At least it's given at 1 second a certain information, right? At 1 second, how much is the position? 2. So, if by any chance we get the area under the curve between 1 second and 6 seconds, right? That area will give what is the displacement between 1 and 6, right? And then we have the original position. So, you know from this equation that delta x is the integral of b dt, because they are asking between what time and what time? 1 to 6. What area you find? Tell me what area we will find here in this graph. Where we have 1, right? We have 1 here. This is 1. This is 2. This is 3. And then go like this. And this is 6. My question, B versus T. If I want to get the area, that will be delta x between 1 and 6. Any question on that? How can I get this? This area will be positive or negative? This area will be positive or negative? Negative. And additionally, you know what is XO? What is X at 1? X at 1? 2. You can move to this side and you can find X. Alright? So this is question 17 is similar. They are asking for the acceleration or magnitude of the acceleration when the velocity is 0. Again, you get the time when the velocity is 0, and then you get the acceleration, which is. The next graph is acceleration versus time. Can you see? They will ask what is the velocity. If they are asking in the acceleration versus time graph what is the velocity, what you need to do? Take the integral, which is the area under the curve again. Any question? 19. So I am giving hints. I'm very quick. You have to follow quickly because this is the study guide. You have to be done by you, not by me. But I am giving hints. If then in the next class you have questions about this study guide, come with the question. Okay. 19 is motion at constant acceleration. Motion at constant acceleration, or uniformly accelerated motion, which is this. How do we proceed here? Simple. A proton moving along the x-axis has an initial velocity of 4 times 10 to the 6 meters per second. 4 times 10 to the 6. What is that? How can we label that when we are solving the problem? Yeah, 4 times 10 to the 6. It doesn't matter. How can we label? V initial. How do we label V initial? VO. Right? VO is 4 times 10 to the 6. And a constant acceleration, when they said a constant acceleration, what they are implying? They are nice, but they are implying, physically speaking, that you have to use what? The big 3. That's the implication. What is the velocity of the proton after it has traveled a distance of 80 centimeters? Can you see that there is a inconsistency of the units? Check for inconsistency of the units. What can you note? The velocity is in meters per second, and the distance in centimeter. Which one you have to change? Centimeter to meter, right? How much? What can we do in order to change that 80 centimeter to meter? We divide by what? 100. Once we have everything consistently, then we look for the formula. What do we have? V initial. What else? Acceleration. What else? Distance. What else? And what we need to find? V final. Which equation? The third one. Is that clear? Because it's the time independent. So it's the one that is time independent. Which of the 3 is time independent? The third. So whenever you have information about distance but no time, you know that is the third. Good. 20. And this, we go okay, that was a motion at constant acceleration. One at constant acceleration. The other one at constant acceleration is, so what about if I give the time? V initial, V final, and the time. Find the acceleration. Which one you use? The first one. I give the initial velocity and the time, or the position. I want to find the time. Which equation you use? The second. This is the key with these 3 equations. So they are elementary problems, very basic. I give this, I give this. Sometimes you will need to use more than one equation. I don't give the acceleration, but I give V initial, V final, and the time. And I will ask for the distance. What can you do? You use this to find the acceleration. Once you get the acceleration, you go to the other equation and find whatever you need to find. This is the key when we have this type of question. Any question? For uniformly accelerated motion along X. Along Y.